Hello everyone, I am KUMUDA. The topic I am going to talk about is analog to analog conversion. Before that, we need to know about analog transmission. Analog transmission is a method of conveying information using a continuous signal which varies in amplitude, phase, or some other property in proportion to that information. To send the digital data over an analog media, we need to convert it into analog signal. There are two cases. The first one is band pass. A band pass is a band of frequencies which can pass the filter. And next one is low pass. Low pass is a filter that passes low frequency signals. When the digital data is converted into a band pass analog signal, it is called digital to analog conversion. When the low pass analog signal is converted into band pass analog signal, it is called analog to analog conversion. Now, analog to analog conversion. Analog signals are modified to represent analog data. This conversion is also known as analog modulation. Analog modulation is required when band pass is used. Analog conversion can be done in three ways, that is, amplitude modulation, frequency modulation, and the phase modulation. The first one is amplitude modulation. In the amplitude modulation, the carrier wave is varied according to the instantaneous amplitude of the modulating signal, keeping phase and frequency as constant. In this modulation, the amplitude of the carrier signal is modified to reflect the analog data. Amplitude modulation is implemented by means of a multiplier. The amplitude of modulating signal, that is the analog data, is multiplied by the amplitude of carrier frequency, which then reflects the analog data. Here, the frequency and the phase of the carrier signal remains unchanged. AM is normally implemented using a simple multiplier because the amplitude of the carrier signal needs to be changed according to the amplitude of the modulating signal. The graphical representation here shows the amplitude modulation. AM bandwidth. The total bandwidth required for AM can be determined from the following formula. BAM is equals to 2B. That is, the modulation creates a bandwidth that is twice the bandwidth of the modulating signal and covers a range centered on the carrier frequency. The next one is frequency modulation. The modulation in which the frequency of the carrier wave is varied according to the instantaneous amplitude of the modulating signal, keeping the phase and the amplitude as constant. It is called frequency modulation. In this modulation, the frequency of the carrier signal is modified to reflect the change in the voltage levels of the modulating signal. FM is normally implemented by using a voltage controller oscillator as with FSK. The frequency of the oscillator changes according to the input voltage, which is the amplitude of the modulating signal. The bandwidth of the frequency modulated signal varies with both deviation and modulating frequency. The graph here shows the frequency modulation. FM bandwidth. The total bandwidth for FM can be determined using the formula BFM is equals to 2 into 1 plus beta into B. The actual bandwidth is difficult to determine exactly, but it can be shown empirically, that is several times that of the analog signal, or it is 2 into 1 plus beta into B, where beta is a factor depends on the modulation technique with a common value of 4. The next one is phase modulation. The modulation in which the phase of the carrier wave is varied according to the instantaneous amplitude of the modulating signal, keeping the amplitude and frequency as constant, is called phase modulation. In this modulation, The phase of the carrier signal is modified in order to reflect the change in the voltage of analog signal. Phase modulation is practically similar to frequency modulation, but in phase modulation, frequency of the carrier signal is not increased. It is normally implemented using a voltage controlled oscillator along with a derivative. The frequency of the oscillator changes according to the derivative of the input voltage, which is the amplitude of the modulating signal. The graph here shows the phase modulation. PM bandwidth. The total bandwidth required for the PM can be determined by the formula Bpm is equals to 2 into 1 plus beta into B. Although the formula shows the same bandwidth for FM and PM, the value of the beta is lower in the case of PM. That is around 1 for narrow bandwidth and 3 for wide bandwidth. Thank you.